When players actually play a game, of course, they'll want to save the state of the game and subsequently reload them. So if I finish playing now and I come back in a few hours or tomorrow, I want to be able to load the game from where I left off. Now let's have a look here. I've just started the game. Where am I? I'm in room 0 and I just have a lamp. But I've previously explored the game a bit, and so I saved it by clicking the save button, and now I want to load my saved version of the game. So that's what I've done now. It says game loaded, and let's see what's changed. So I was in room 0. Where am I now? I'm in room 4 because that's where I was when I saved the game. And what have I got in my inventory? I previously only had a lamp, but now I've got a lamp and a wombat again because that is what I had when I saved the game. So let me see how that's implemented. Now, in an earlier project I showed how you can map on objects to records and save records to a typed file. You can't just save objects to a typed file. That was a simple way of dealing with a very simple project with very simple types of data. But here I've got very complicated data. It could be a network of linked objects, a map containing rooms, rooms containing objects, objects potentially containing other objects. So I need a more powerful way, a more flexible way of saving my data. Now what I've done is I've implemented this procedure called write to stream, and it takes a T file stream object. Streams are special types of classes that can manipulate sequences of bytes. Bytes are just small chunks of data, and all other types of data are fundamentally formed from bytes. So you can save any type of data to a file stream. So I've got this file stream here, which is called fs. Now, because I don't know which type of object I'm writing at any given point, because I can take and drop different objects around my map, I could be saving at any point in my save process a different type of object. So I need to know what the class of that object is, so I can get that with self class name. And then I call write buffer. Write buffer is a method of tFileStream, and I write the class name into the file stream. That puts the class name, the actual string describing the class, into this stream of bytes, and I have to write a specific number of bytes into that stream, and to get the correct number of bytes to store the class name I use size of, as here. Following that I write name and description. Now for different types of objects saved to the stream, let's have a look. For example, if I go further down to look at a descendant object, let's say room object. So when I call room object write to stream, it calls inherited write to stream, so that would save the name and the description of the room, and then it calls write buffer to save its own additional data, which is here the exits, so it's 4 integer values. Now in fact roomob descends not directly from thingob, which saves name and description, but from thingholderob. So roomob calls thingholderob write to stream, inherited write to stream, and that calls thingob. This code goes through the list of things, because remember thingholderob is a special type of class which maintains a t-list, a list of items, and it goes through those items and it calls write to stream for each of those items. So each data item, each object writes its own data into the stream, even if it's a list of objects. So you can see by doing this, I'm able to get each object of each different type, of each different class, to write its own data to a stream. So when, let's have a look how this is done. So when I call save game, that's imp save game, that's the implementer, and that executes this code. It first of all calls map write to stream. Map has the effect of calling write to stream on each object, because map is a thingholderob type, and as I've just shown, that iterates through all the objects that it maintains. Each of those objects writes its own data into the stream, and finally I write player to the stream. And I've got a bit of try except exception handling to deal with unexpected errors. And when I load the game, I do the reverse. I open a T-file stream for reading, then I call free on the current map and on the current player. I create a new map which has no real data, it's just a holder for the data that's going to be initialized with, and a new player. And then I read, using read buffer, I read the class name for each object that was stored. Remember, I stored the class name as the first data item for each object, and I read only the amount of data that is required to read that class name using size of. And then I continue reading through the stream to reconstruct the map and all the objects and the player and anything that the player needs to be initialized with. So stream handling and this process called serialization, whereby objects save and restore their own data, it's really quite an advanced subject. So I would advise you don't worry too much if you can't understand all of the nitty-gritty details of how this works. Examine my code and, of course, use the help system to find more information on streams and how to use them in the Lazarus or Delphi help files. And run the code and experiment to see how it works, and try saving and restoring and seeing how the streaming simplifies saving and restoring complex networks of objects.